Now, just as a matter of curiosity, this identity is actually really, really important. It's so important it even has a name, okay? It's called, let me get a new sheet here. It's called Pascal's identity. Now, you're like, Pascal, who's he? He was a French mathematician, Blaise Pascal, and he's most famous, well, at least I think for most people who learn maths, he's most famous for his triangle, Pascal's triangle. Okay, and how do you build Pascal's triangle? The way it works is you start with these three numbers up the top. They're kind of by definition, but then to get each of the subsequent numbers, what you do is you add up the two numbers above each number. So for instance, to get this 2, you take these two ones and you add them up. Okay, or to get this 4, you take the 1 and the 3, or the 6 comes from the 3 and the 3, right? Now, one of the most important things, the most important insights in binomial theorem is realizing that adding up numbers is not the only way to build Pascal's triangle. There's another way to do it. You can write it in all in terms of binomial coefficients, okay? And you could go ahead and get your calculator and verify these results. That, for instance, 2 choose 1 is 2. 2 choose 0 is 1. 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3, and so on. All of these numbers line up exactly. Which is really interesting. There's a lot of theory behind this, and it's a very mysterious kind of thing. Well, not that mysterious once you dig into it. But anyway, what does this have to do with the identity we just proved? Well, we just proved that n choose r plus 1, sorry, yeah, that's right, is equal to n minus 1 choose r plus n minus 1 choose r plus 1. Well, let's just take some values. Let's, for instance, say, or I don't know, let's let n equal 4, okay? And let's r equal, say, 2, okay? So if this is 2, that's 2 plus 1, right? So that's really 4 choose 3, okay? And what do you have on the right-hand side here? You've got n, which is 4 minus 1, choose 2, and 4 minus 1, choose 2 plus 1. So what you've got is 3 choose 2 plus 3 choose 3. Now, can you see what this is doing, right? 4 choose 3, that's over here. And it's saying, well, how do you get that? What's that equal to? Well, it's equal to 3 choose 2 plus 3 choose 3, which is these guys. Okay, and it doesn't just work for n equals 4 and r equals 2. This sort of means, look, for that nth row, you can see the top number in your NCR is which row you're on, the 0th row, first row, second row, third row, fourth row. You pick a couple of terms, r and r plus 1. What they'll equal to is term r plus 1 on the next line. You can do it for anyone, right? So this is a really interesting identity, very, very fundamental. I hope the proof makes sense to you, and good luck with your rest of the study of binomial theorem.